All right, y'all. So in this video, we are going to learn about just one electronegativity exception. So you learned in your inquiry activity that electronegativity is how strongly an atom attracts a pair of electrons to itself when bonded with another atom. Or in short, just how badly an atom wants to grab onto more electrons, how badly an atom wants to add more electrons to itself. And we learned that this increases left to right across the table because that nuclear charge increases, attraction increases. And we learned that it increases from the bottom of the table to the top of the table because there are fewer energy levels, so there's a smaller distance, so there's more attraction. And that is true basically all of the time. Electronegativity increases left to right, bottom to top. The exception comes from your noble gases. They have essentially zero electronegativity because they don't need or even want more electrons. These other elements are trying to reach a full octet. They're trying to grab onto more electrons to fill up that valence level. But as we've said many times, your noble gases already have a full valence level. They don't need more electrons. They don't want more electrons. They are very, very happy with the number of electrons that they have. So in your booklet, we've got this table of electronegativity values, and you can see that in group 2, lithium is the lowest, and then it increases to beryllium, boron, carbon, nitrogen, oxygen, and then fluorine is the highest. And then group 3 is a little bit lower. Sodium is the lowest in that row, and then it increases across to chlorine. And then in group 4, it starts even lower. Potassium's the lowest. Calcium increases all the way to bromine. So it still follows the trend that we learned. It's getting lower as we move down the table from fluorine to chlorine to bromine to iodine. It's getting smaller, and it's increasing from left to right, from cesium to barium all the way across to astatine. It's increasing left to right. But your noble gases are not anywhere in this picture because they have no electronegativity. If we wanted them to be in this picture, they would have to be completely flat to this axis where it says electronegativity is 0.0 because they have basically none. So our trend still increases up and to the right, but it cuts off right before our noble gases. So we should maybe scooch that arrow back just a little bit. So your highest electronegativity element is fluorine because it is the most up and to the right element that is not a noble gas. So here's our example. Which of the following has the greatest electronegativity? And our options are fluorine, neon, chlorine, and argon. Now, before we even look at the other elements, we can rule a couple of these out because neon and argon are noble gases. They're in group 8. They have a full valence level. They have no electronegativity. You might be really tempted to put neon as your answer to this question, but neon does not have any electronegativity. So then looking at our remaining options, fluorine and chlorine are both in group 7. Fluorine only has 2 energy levels and chlorine has 3. The fewer energy levels you have, the closer those valence electrons are to the nucleus, and the more easily that nucleus is able to reach out, grab onto another electron, and steal it for itself. So fewer energy levels, greater attraction, greater electronegativity. Fluorine is the highest.